Properties of exponents are next on our agenda. Natural number exponents. If a is any real number and if n is any natural number, then a to the n is equal to a times a times a times a n times. That is, a to the n is merely a shorter and more precise way of denoting the product of n factors of a. In the expression a to the n, a is called the base and n is the exponent. The process of multiplying n factors of a is called raising a to the nth power, and the expression a to the n may be referred to as the nth power of a or a to the nth power. Note that a to the first power is equal to a. Well, let's put this to use. 3 to the third power, also known as 3 cubed, will be 3 times 3 times 3. Well, 3 times 3 is 9, and 9 times 3 is 27. So 3 cubed will be 27. Okay, I really want you to notice the difference between how we work letters B and C. For B, we have -6 all squared. I said all squared because the whole -6 is inside parentheses and is all raised to the second power. That means we have -6 times -6, which is a positive 36. Okay, look at the difference between this one and the last one. For C, we have -2 to the fourth power. Notice I didn't say all to the fourth power. That's because the negative is not included in this power, only the 2 is. It's not included because it's not in parentheses. So we just leave that little negative sitting there, and then we raise 2 to the fourth power. My little dots aren't working for some reason. There we go. So we have negative 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So -2 to the fourth power is -16. If you aren't quite sure about these last two, go back and watch them again and see if you can understand the differences between them. Okay, how about D? Ooh, we have a negative sitting out front. We have a -2 all cubed, and then we have a 5 squared. So let's keep that little negative out front. Then we cube a -2. And then we square a 5. Keep the negative. -2 times -2 is 4. 4 times -2 is -8. 5 times 5 is 25. Well, what's a negative times a negative? That would be a positive. So we're going to have a positive 8 times 25, which would give us a positive 200. Okay, how about E? We have x to the fourth times x to the fifth. Well, x to the fourth means to write that down 4 times. And x to the fifth means to write that down 5 times. Well, if you multiply 4 x's times 5 more x's, don't you just get x to the 9th power? So do you see a shortcut we could have taken? X to the 4 plus 5 is equal to x to the 9th. You can do this if you are multiplying, that's what the little dot means, if you are multiplying like bases. See, these bases are both x. So if you multiply like bases, you add the exponents. That's one of the properties of exponents. F will be another property of exponents, but let's go ahead and work it out the long way. 7 to the 5th power means 5 7s all multiplied together over 3 7s all multiplied together. What is 7 over 7? 7 over 7 is 1. 7 over 7 is 1. 7 over 7 is 1. You end up with 7 times 7, or 49. Over 1, of course, but that's just 49. Well, the shortcut for this one is 7 to the 5 minus 3 is 7 squared, which is 49. If you are dividing, that's what the little bar means, if you're dividing like bases, the 7s are the bases, then you can subtract their exponents. Okay, so what happens when we start throwing zeros in there for exponents, or negative numbers in there for exponents? We already know about these first three. How do we know that 3 to the 0 is equal to 1? This is what I want you to do. Divide each of these steps by 3. "27 divided by 3 is 9. 9 divided by 3 is 3. What's 3 divided by 3? It's 1. So if we decrease these exponents by 1 each time, it's just like dividing by 3 each time. That's how you can know that 3 to the 0 power is equal to 1. And for future reference, anything to the 0 power is equal to 1, except for 0 itself. We'll get into that later. Okay, so if we continue this pattern, we need a little more room. Divided by 3, divided by 3, and divided by 3. If we keep dividing by 3, what is 1 divided by 3? 1 divided by 3 is 1/3. Ah, okay. So what is 1/3 divided by 3? That's the same thing as 1/3 divided by 3 over 1. Do you remember how to divide fractions? You bring the first one down, change the multiplication, and flip the second one over. So 1/3 times 1/3 is really 1/9. So 1/3 divided by 3 is 1/9. So what do you think 1/9 divided by 3 is going to be? That's 1/9 divided by 3 over 1, which is 1/9 times 1 over 3. But when you multiply these, you get 1 over 27. Okay, so let's see if we can see a relationship between these three and the first three. What is 3 cubed? It's 27, right? But when we stick that negative in there, it means we flip that 27 over to the denominator. 3 squared is 9, but if the 2 is negative, it becomes a 1/9. 3 to the first power is 3, but when the 1 is negative, you flip it over to get 1/3. So a shortcut, so you don't have to do all of this stuff and all of this stuff. The shortcut will be to remember, if you have a negative exponent, you just flip it over. Flip it to the other side of the fraction. Okay, let's try some. On all of these, we can use the properties of exponents, or we can just write them out the long way. It's really up to you. This will be y to the 4 minus 8 if we use the properties of exponents. Well, that's y to the negative 4, or 1 over y to the 4th. I'm really sorry about my dog barking. I hope it's not too distractful. Sorry about that. Okay, so if you wanted to write this out the long way, it would look something like this. You have 4y's over 8y's. And you just reduce it. Y over y is 1. And you're left with 1 on the top, or in the numerator, and 4 of them in the denominator. Okay, so let's try B. Reduce your coefficients first. 8 over negative 4 will be a negative 2. Well, what is x cubed over x cubed? You have 3x's over 3x's. They all reduce to 1. Okay, do it the other way. X to the 3 minus 3 is x to the 0. And anything to the 0 power is 1. So we just have negative 2 times 1, which is negative 2. Okay, how about C? 5 to the 0 power is 1, and 5 to the negative 4th power is 1 over 5 to the 4th power. Well, what is 1 over 5 to the 4th power? 5 to the 4th power is 625. Okay, how about D? This time we have 1 over t to the negative 5. Remember, if you have a negative exponent, you just flip it to the other side of the fraction. So that means this one comes up here to the top. And when it comes up here, you just have a 1 in the denominator. So you end up with t to the 5th power. That one was too easy, wasn't it? Ooh, E looks really interesting. Let's see. This 4 is on the outside of the parentheses, which means everything in there gets raised to the 4th power. So we're going to have this. Okay. Well, this looks similar to what we've been doing. We can only add exponents when there are like bases. So x cubed, x cubed, x cubed, x cubed, all of those have like bases. Since they do, we can just add their exponents. 3, 6, 9, 12. So we get x to the 12th power. How about these y's? Y times y times y times y will be y to the 4th power. So x to the 12th, y to the 4th would be simplified. Do you see a shortcut for this one? I'm going to use something that's not correct mathematical terminology, but I think you'll understand what I mean. It's kind of like you're distributing this to the exponent. X cubed to the 4th power is x to the 12th, and y to the 4th is, of course, y to the 4th. If you have x cubed to the 4th power, here you have a power raised to a power. That's different than when you're multiplying like bases. I'll show you that in just a second. You have a power to a power, which means you can multiply the powers. I want you to notice the difference between x cubed to the 4th, which is x to the 12th, and x cubed times x to the 4th. Here you're multiplying like bases, so you add the exponents. This one would be x to the 7th.